a lot of different research that's going on within the graduate students within the community. And I guess it's kind of the intellectual equivalent of like Indian food, sunsets, and long walks on the beach. They will be hopefully, soliciting new collaborations and basically trying to give a little sense of what their own research is to you, and hopefully you will form new collaborations and potentially even postdocs and faculty positions in the future. And so with that said, that was my lightning talk on lightning talks. And we're going to go ahead and get started. Again, this is 1 to 2 minutes for them to talk. There are no slides and no questions. So most of them do have posters that are being presented, and so please track them down at their posters later. So we'll get started with Sandra. Yeah, can the lights come up back here, please, Ricky or Ashton? You come just go ahead and
okay. Can everybody hear me all right? Okay. Hi, I'm Sandra Blevins. I'm a graduate student at the Catholic University of America in Washington, D.C. And I'm doing my dissertation work with Klaus Pontoppidan at the Space Telescope Science Institute. And I'm presenting a poster for this conference. It's at 34B, and it's snowline localization in protoplanetary disks. So the snowline is the radial distance from the central star where water transitions directly from gas to ice. And it sort of marks the boundary where gas giant planets may potentially form in developing systems. So the goal of my project is to measure the snowline location for 4 classical disks surrounding young solar analogs in order to link the amount of planet-forming materials available in these young systems to the evolutionary stage of the disk. And ultimately, we hope to gain a deeper understanding of planet formation in the early solar system. So, interesting factoid about myself is that back in 2003, I was part of a conservation genetics team that tracked deep into the rainforests of Kalamatretra in Madagascar, and we hand-caught chameleons for population genetic studies, and our team actually discovered a new leopard lemur or sportive lemur species. So please stop on my poster. I'm going to try to be there over most of the lunch sessions, but you can catch me at any time, and I'll be happy to answer any questions you may have. Again, my name is Sandra Blevins. Thank you for your attention.
Can you guys hear me all right? All right, thanks. Good afternoon, everybody. My name is Jonathan Acez. I'm from the town of Guilderland in upstate New York. I'm currently a second-year graduate student at the University of Colorado Boulder with a research focus in low-thrust trajectory optimization. I've actually been out here since May for a summer internship at NASA Ames in the Mission Design Center. We're actually doing a lot of work to prove that we can visit some of the objects we've been talking about for budgets that aren't billion-dollar budgets, but maybe less than a quarter of that. My primary focus, though, on the internship is a project called Light Force and fighting the cascading effects of the Kessler syndrome, proving we can mitigate collisions with photon pressure from ground-based lasers, just an array of 20 kilowatt ground stations perturbing the debris objects and avoiding those collisions. I'm also moonlighting for a company called Moon Express. It's a team of all-stars right next door to Survey. I'm working on building low-energy lunar transfers, and that's really exciting because this company is going to visit the moon once or twice before I'm done with school, and shortly thereafter bring something back. Back here on Earth, I'm a big fan of distance running. I competed for my undergraduate institution, Syracuse University, in cross-country and track and field. I don't have a poster or a talk for you all this week, but I'll be around and looking forward to some good conversations. Again, my name is Jonathan Acez. Thank you.
Hello everyone, my name is Kavan Hazeli. I am a postdoc at Johns Hopkins University. I'm working in the Hopkins Extreme Material Institute. For the one who doesn't know about us, we are interested in studying the mechanical behavior of the materials in the extreme environments. What does that mean is, for example, we are interested to study what is happening in the mechanic perspective of the material in the extreme direction. For example, like car accident, when asteroids comes in, when aircraft goes down. Our interest is to study the science happens in those conditions. The ultimate goal for us is to develop the realistic mechanical-based models that predict the material behavior and and impact consequences. To achieve this goal, we are trying to develop high-fidelity experimental results to push the boundary of the modeling schemes. The detail of our work will be explained by my colleague Charles on Wednesday morning at 11 a.m. and he will give a quick spiel today about his research as well. Thank you.
Can you even see me? My name is Jamie Milaro. I am getting ready to graduate from the Lunar and Planetary Laboratory at the University of Arizona. I've been working there with Dr. Shane Byrne. And most of what my work focuses on is looking at how thermomechanical processes like thermal fatigue or thermal shock, what kind of role do those processes play in the evolution of landscapes over geologic timescales. So the work that I am presenting this week looks at stresses caused by diurnal cycling, primarily on airless bodies. We're looking at the Moon, Vesta, Phobos, and a variety of other near-Earth asteroids. And we're trying to quantify what are the magnitudes of stresses that are being induced on rocks on these surfaces, and what are the distribution of stresses within those rocks, and trying to understand what sort of contribution the breakdown might have to the production of regolith on these bodies.
Hello everyone, I'm Charlesmire. Before I start, I just want to ask, I saw some people in the back with their cell phones on. If you can please do me a favor and take a quick picture, because it's not every day I'm going to be standing here with a NASA logo in front of me. That's the first reason. The second reason, I want to send it to my mom. So I'm Charlesmire. I'm from Johns Hopkins University, and like Yvonne said, we do basically modeling and experimental stuff on materials in extreme environments, and obviously space and space and impact and the weathering effects in space are really important factors in really extreme conditions. So that's what got us looking into kind of what Jamie talked just before me about what exactly are the temperature effects and the thermal effects and the breakdown of asteroid rocks or rocks on the asteroids and the production of regolith and evolution of this regolith. So I just started my research this year. I'll be presenting a talk on what we started, like the preliminary results on Wednesday at 11 a.m. in room 117. So if you did take my picture, meet me afterwards. If you don't catch me up after this time, I'm going to be in room 117 on Wednesday at 11 a.m. I'm Charlesmire, and thank you all.
Hi, good afternoon, everybody. I am Elise. I did my undergraduate at SUNY Buffalo, and I am a very recent doctoral graduate from University of Hawaii at Manoa. I worked with Sarah Fagents there, and I'm interested in studying the fluid and thermal physics of lava flows and how different planetary environments and different substrates are going to affect lava flow emplacement. For part of my dissertation research, I was actually able to melt basalt and pour it onto lunar regolith simulant in order to measure lava substrate heat transfer. I actually have a talk here tomorrow in this room at 9:50 in the geology parallel session. I'm going to be talking about the results of some fieldwork I did where I used Hawaiian analog locations to try to assess the accuracy of some LROC interpretations of lunar Maori flow thicknesses. So that talk is going to be in this room tomorrow at 9:50. It'll be great to see you guys. Thank you.
Great, thank you. Thank you all so much. And can we please give all of our speakers for this round another round of applause, please? We will have a 10-minute break.